we have one triangle. For example, this triangle. By the way, no, this is the right 90 degree here. This corner, this is square, small square indicate 90 degree. This is the right triangle. So far, any triangle is right triangle. After, no. After we complicate more, but so far it's okay. And this is my famous angle theta. Remember the Greek letter that we use frequently, theta. Theta. Okay. Entonces I call, for example, this side, que es totally in front, theta, is the opposite. Opposite side. Opposite side. Therefore, opposite side. Abbreviation opposite. OPP. This side, que is here, is adjacent side. Is the side is, you know, on the floor, huh? Maybe on the floor. It's adjacent. The abbreviation is adjacent. Let me put in blue color. Adjacent. And the yellow is the hypotenuse. HYP, hypotenuse. Hypotenuse. Okay. Okay. So now we have six combination to write the ratio and between the ratios. 6 combination. And this ratio receive a specific name. So you need to, so far today, associate name and the ratio. For example, sine theta. Sine theta. You put a parenthesis because this is a function notation, right? F of x, remember, f of x is a function notation. Then you put a parenthesis. Some people omit the parenthesis, but it's not totally incorrect, but it's okay. Sine theta is the ratio between opposite over hypotenuse. Opposite over hypotenuse. Cosine theta is the ratio between adjacent over hypotenuse. And tangent theta is the ratio between opposite and adjacent. Okay, this is sine, cosine, and tangent. It's the most important trigonometric function. However, we have 3 more, que es the reciprocal of this. O sea, cosecant theta. Okay, this is sine. The name is sine, cosine, tangent. This is cosecant. It's a name. Name. The abbreviation is 3 letters. Not always the first 3 letters, no? But in this case, cosecant, no, it's different. Is the reciprocal of this. It's hypotenuse over opposite. Please putting off the microphone. I hear noise. All right, I detect immediately who have they open the microphone. All right, let me see. Okay, thank you. Okay, entonces cosecant es, look, es the reciprocal of this guy. I flip it, reciprocal. Okay, likewise, secant theta is reciprocal of cosine, hypotenuse over adjacent, and cotangent is adjacent over opposite. So the name is this is secant, and the name is cotangent. Cotangent. So you see, bueno, professor, how I memorize this information? Well, using your common sense and imagination, there are several mnemonic devices to remember. One mnemonic device, famous mnemonic device, is sine, opposite, hypotenuse. Cosine is adjacent, hypotenuse, and tangent is opposite, adjacent. Entonces es Sakatoa. You remember Sakatoa? This is, that part is sine, look, opposite. This O is opposite, divided by hypotenuse. This part is cosine, adjacent over hypotenuse. And tangent is opposite over adjacent. Sakatoa. Sokatoa. I don't like this, but okay. Another student can learn visual. Sine is opposite, red color, over hypotenuse. Cosine is the yellow, blue divided by yellow. And tangent is red divided by blue. And the other trigonometric function que es complementary is the reciprocal. Entonces you need to know by memory que cosecant es reciprocal sine, they are connection, the family, secant and cosine, and tangent and cotangent. Okay? And the mnemonic divide, Sokatoa. You remember the music, and you, it's a mnemonic divide. However, you can use my cheat sheet here, anytime. And in the cheat sheet, you see definition. Okay, let's see a couple of the example of the practice, a little bit definitions of the trigonometric function. Okay, I forgot. No, okay. Listen to me. This is important. No student record. I am recording, and you remember, professor record, because so you are leaving, for example, so you start recording and you are leaving, your link is disconnecting. So see, we have in two videos separately. So now you only remember, professor, you forgot record. I forgot always. But okay, let's see, you stay here, I suppose. Okay, example 1 to understand definition of the trigonometric function. Suppose is one triangle is given, like that. Of course, right triangle. And this is 24. This is 7. And this is 25. And the question says, find the exact value of the 6 trigonometric functions. So I need to find, and this is theta. Sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. According to the definition, sine is opposite over adjacent, 7 over 25. Make sense? Cosine is 24 over 25. Adjacent divided by hypotenuse. Tangent is opposite divided by adjacent. This is reciprocal of this. This is reciprocal of this. And this is reciprocal of this. End the story. Super clear?
So the angle like change.
I don't understand anything. Speak slowly.
Can you hear me?
I hear, but confusing. But, like that.
Okay,
come on, slowly. What's your question?
Yes, Professor. My question is about the angle, because the angle change in that triangle. That is why, like the opposite side.
Absolutely, you're right. Suppose that I have another angle here. I want to call alpha. So this number change because the opposite of alpha now is 24. The adjacent of alpha is 7. And the hypotenuse stays the same. Yes, of course. You are right. This is your question?
Yes, it was. Thank you, Professor.
Example 2. Suppose now I want to complicate a little bit. We have a triangle again. co-right triangle. Hypotenuse 5. This is 3. And he has no idea. Question mark. And the same question. You find the 6 trigonometric function. Sine theta. This is theta again. Cosine theta. Tangent theta. Cosecant theta. Secant theta. And cotangent theta. Do you see I organize in that way? Because I know very well the correspondence between sine and cosecant, cosine and secant, and tangent and cotangent. Okay, so in this example 1, we have the 3 sides, but in this, no. But we can apply the Pythagorean theorem. Let me show you. Pythagorean theorem. I know the Pythagorean theorem que say que c squared is equal a squared plus b squared. Who is that? In one triangle, the leg I call AB, and the hypotenuse C, always. And this is the relationship state this. So basically, in order to find the missing side, is the leg, is a square root 5 squared minus 3 squared. And minus because somehow I isolate B, for example. Suppose this is A, this is B, and this is C. Is 25 minus 9 is 16, and the square root of 16 is 4. Okay, so now sine is 4 over 5, opposite is 4, hypotenuse is 5, cosine is 3 over 5, tangent is 4 over 3, cosecant is 5 over 4, secant is 5 over 3, and cotangent is 3 over 4. Boom. Final answer. Everyone follow me?
Yes.
Okay, this is definition. Let's see, Mr. Go ahead. Question. Come
on. That the way you solve for B, is it the same for every other letter?
Yes. Yeah. Okay, the only thing, mister, que you need to know. Suppose que the one letter is missing. Suppose this is 3, this is 5, and I don't know this. So the formula is 5 squared minus 3 squared. However, si the hypotenuse is missing, suppose 4, 3, entonces square root 4 squared plus 3 squared. Make sense?
Okay. Is it only for the hypotenuse or?
Only for the hypotenuse, plus. Si es one letter is missing, es minus.
Okay.
Super.
Thank you.
Okay, I want to erase the board, right? Let's do a couple problems. Suppose now I want to complicate your life. Suppose example 3. In example 3, we have one trigonometric function is given sine theta is equal radical 5 over 3, comma, and cosine theta is equal to 2/3. And using the definition of the trigonometric function to find, for example, one specific, cotangent theta. So you don't need to find the 6 trigonometric functions. So 2 trigonometric functions is given, sine and cosine, and I need to find cotangent. Do you understand the problem?
Yes, Professor. We're gonna just flip.
We have 2 possibilities of solution. Solution 1, solution 2. This is the beauty. There are many ways to do this problem. Now, solution 1 is you build your own triangle. This is 90 degree. This is my famous theta. Entonces, I know, according to the definition of the sine, this guy is opposite. And this guy is the hypotenuse. The 3 is the hypotenuse. And the square root 5 is the opposite, no? And this is adjacent. And this is hypotenuse. They are perfect coincidence. Look, the same hypotenuse, 3, 3. This is 2. This is my triangle. And when you have a triangle, the rest is piece of cake. because I know que cotangent, cotangent es reciprocal tangent, or you know que is the adjacent divided by the adjacent divided by opposite. And who is the adjacent in our problem? Cotangent theta. Adjacent is 2. And the opposite is radical 5. And leave it like that, never. You rationalize. Multiply by radical 5. The answer is 2 radical 5 divided by 5 because I know que radical 5 times radical 5 is 5. And this is the final answer. Do you follow me?
Yes, Professor.
This is one possibility. Always do the triangle. Another possibility, the fantastic possibility, is using the identity. The identity. What identity? The identity que I provide you in the cheat sheet. Let me try. This cheat sheet we use it every day, guys. Every day we using this cheat sheet. Let me see here. MAC1114 cheat sheet. Boom. Okay, the second page. I want to see the second page. Do you have that?
Yes, you send us.
Okay. Entonces, one fantastic possibility is we are using now. Guy, I promise you we are using every formula, but not today, of course. We're using this. Look, that formula. Because I need to find cotangent, no? So cotangent, I copy the formula. The formula says cotangent theta is equal to cosine theta divided by sine. Cotangent theta is given, it's 2/3. And sine theta is given, is radical 5 over 3. I suppose you remember that, right? Okay, now what should I do? Division. To divide this, you copy the first fraction 2/3, time flip the second, get 3 over 5. 2 over radical 5, sorry. The 3 is cancelled, and it's 2 over radical 5. It's exactly the same, we get that. After the rationalization, we get that. Super? Super good or no?
Super.
Excellent.
Yes, Professor.
Either way, the way you prefer. Let me know when that. Go ahead.
Professor, I'm
Go
sorry.
ahead.
If the hypotenuse is actually different, in that case, what would happen?
Say again?
If the hypotenuse is different,
No. Well, no. Okay. Let me see in the next. It's no different. It's the same triangle, so it's the same hypotenuse. Maybe when you set out the ratio and you reduce and lower time, they are different numbers. But you try to find using the common denominator. Okay, because the hypotenuse is the same for both trigonometric function because corresponding with the same angle and the same triangle. Okay?
gotcha. Thank you.
Excellent. Okay, let's do one more example. And let's do it in both ways, using the triangle and using the identity. The identity is waiting for us in this piece of paper. And we use it anytime you need. Okay. Example 2. Okay, I have sine theta equal 7 over 4. And it's also giving cosine theta is 3 over 4. And I need tangent. Tangent theta. I don't know. What do you consider much better, doing the triangle or using the identity?
Identity, Professor.
Identity, Professor. Okay. What identity are you using? This one, I suppose, no? Look. right?
Yes, it is, Professor.
Ajá. Entonces, tangent theta es igual sin theta divided by cosine. Okay, that formula we use it every day, guy, in this class, and you use it every day in calculus. Entonces, sine es radical 7 over 4 divided by 3 over 4. Es radical 7 over 4 times 4 over 3. The 4 is cancelled. You can do that here directly if you want. Es radical 7 over 3. End the story. We finish. Okay? Okay. Clear or confusing? Okay, entonces we have several identity que es fundamental in that part. Que es look, take a look this. The reciprocal identity. So this is tangent cotangent, que I illustrate in two examples. But we have, for example, reciprocal. Cosecant, secant, cotangent. Is the reciprocal of sine, cosine, and tangent respectively. And in opposite direction is like that. This is reciprocal, the collection of the reciprocal function. Okay, maybe we're using. Because I am familiar with the sine, cosine, and tangent. I am not familiar with the secant, cosecant, and cotangent. But if you find sine, you flip it, and you get cosecant, and so on. And the super important Pythagorean identity. Let me write here because it's extremely important. Sine square, any angle, plus cosine square, any angle is always equal 1. Always. See, the angle is the same. See, the angle is different? No. But if the angle is the same, yes. For any angle, 30 degree, 45 degree, any angle. Tangent square theta plus 1 equals secant square theta. It's another Pythagorean identity. And 1 plus cotangent square theta is equal cosecant square theta. Guy, this is extremely important. Memorize this or little by little. It's a process. I give you the cheat sheet. I suppose when you're working with the cheat sheet several times, little by little you memorize this. Little by little. It's a Pythagorean. So far, we have a family of the identity. Tangent, cotangent, reciprocal, and Pythagorean. Okay, I'm bringing some problems to practice a little bit. Suppose que in one test is given that problem. Look, example 3. Compute that. Tangent 20 degree minus sine 20 degree divided by cosine 20 degree. Compute that. Question mark. I have no idea. Well. I go to the tangent identity. Yeah, I know that the division sine any angle divided by cosine the same angle is tangent. So you replace. You bring down tangent 20 degree. Yeah, I know by this chi que sine divided by cosine is tangent of the same angle. And tangent 20 minus tangent 20 is 0. Super. Example 4.
Sorry, Professor, that's it?
That's it.
Oh.
It said the question say compute that, question mark, compute that. Suppose another. Sine square pi over 12 in radian plus 1 over secant squared pi over 12. Compute that expression. I have no idea what is that. I have no idea what is that. When I use a combination of the identity. Look, I know the reciprocal. Look, the reciprocal. Let me make a zoom. I know que reciprocal secant es cosine. Look, I'm using this. Reciprocal secant is cosine. So 1 over secant. Sorry, this one, much better. 1 over secant is cosine. Entonces, I replace. This is sine squared pi over 12. Just bring down. Plus, this is cosine squared pi over 12. Because I know que reciprocal secant es cosine. Of course, square. The square stays the same. Y according to the Pythagorean identity, sine squared plus cosine squared of the same angle is equal to 1. So basically, for solving this problem, you apply two identity. Reciprocal of secant is cosine, and sine squared plus cosine squared is equal to 1. I bring another. Suppose example number 5. Everyone follow me? This is very straightforward, no?
Yes, Professor.
Well, okay. Suppose sine 55 degree. Multiplication by cosecant 55 degree. I have no idea. I go to the cheat sheet. And we apply again the reciprocal. Entonces now in my opinion, sine stay. Because sine is, I feel comfortable with the sine, cosine, and tangent. I don't feel comfortable with the cosecant. Secant and cotangent is weird for me. But I know que cosecant here is reciprocal sine. So I replace by 1 over sine 55. Okay, so now sine 55 divided by itself, because 1 is invisible, you know, is sine 55 divided by sine 55. Es obvio que es 1, ¿no? Es obvio que es 1. Okay, the answer of this is 1. One more and that's it. Sine square 55 degree plus cosine square 55 degree is equal, I have no idea. So you need to remember in the cheat sheet, look at that. Make a zoom. Sine square plus cosine square is equal to 1. When it's the same angle. Si es different angle, no. Pero it's the same. 55, 55 is 1. Okay? So this the question say question mark. I have no idea. However, using the Pythagorean identity, sine square plus cosine square is equal to 1. Super easy, eh?
Professor, I have a question.
Go ahead.
When do we know that we need to stop?
Want to practice? Practice. We have this is the problem, no? How do you know what dress, what shoes you need to buy? No, you go to the store, you have several, and you need to make a decision. So there are different ways. There are no unique way for solving the problem. We have a lot of equations. We have a lot of identity. We using the trigonometry, using geometry. Little by little, you create your own habit. I want to explain different way, and you select the way you prefer. Okay?
Okay, thank you, Professor.
Let's practice a little bit definition. Okay, it's the most important now. For example, I give you, okay, I want to erase everything. Well, everything even the cheat sheet. I want to, boom. Okay, suppose it's given in this example sine theta. Sine theta is equal to 4/5. Find tangent theta. In this case, it's giving only one trigonometric function. So in this case, we cannot use identities because identity relate to trigonometric function. However, you have only one. So you have only one, so the solution one, so using the triangle is the best way. We draw one triangle, 90 degrees. I call this corner like a theta. And I suppose, according to the definition, this is opposite. This is hypotenuse. Hypotenuse 5. Opposite is 4. I need to find adjacent, is square root 5 squared minus 4 squared using Pythagorean. 25 minus 16 is 9. And square root of 9 is 3. So I know that this segment is 3. And tangent by definition is opposite, which is 4, divided by adjacent, which is 3. And this is the answer. You know that it's no big deal, eh? It's only practice. Memorize definition. Sohcahtoa. Do you like Sohcahtoa?
Yes, I do. It's much easier.
Okay. Okay, one more example. Secant theta equal 13 over 12. And you need to find cosecant theta. Okay, I have no idea, totally lost. There are many ways to do this. Okay, you are doing the triangle, of course. I call this cone theta, always, this is right. Okay, now secant, I have no idea, I lost. However, I know que secant is the reciprocal of cosine. Reciprocal. Entonces, if you want to find cosine, is 12 over 13, right? Makes sense, right? Or you memorize que this is hypotenuse and this is adjacent. But in my opinion, it's easy to see it like that. This is adjacent and this is hypotenuse. Hypotenuse 13, adjacent is 12. And this side is square root 13 squared minus 12 squared. 13 squared, 169, 144. And when you subtract in this guy, 169, by using my calculator, of course, 169 minus 144 is 25. And square root 25, 5. That this side is 5. So you are ready to apply cosecant, but I don't remember very well, Professor, the definition for the cosecant, but I remember very well the definition of the reciprocal, que es sine. Sine theta is the reciprocal of cosecant. Therefore, cosecant is reciprocal of sine. But sine, I remember, sine is opposite que 5 divided by hypotenuse que es 13. And cosecant is the reciprocal que es 13 over 5. Boom, final answer. Do you see it's easy? So the only thing that you need to memorize, or somehow you memorize in the definition is Sohcahtoa. Sine, cosine, and tangent. The other is reciprocal. Okay, you matching by pair, no? What is the pair que matching? Cosecant matching with the sine. Secant matching with the cosine. And tangent matching, or cotangent, sorry, matching with the tangent. Doesn't matter the direction. Clear or confusing?
Clear.
Let's practice. Little by little, you understand this. Suppose another example. Let me see. Okay, suppose this. Suppose que sine is given. So find the value, so they want sine theta equal 1/3. And you need to find the rest of the trigonometric function. So let's do it using two solutions. The solution of the doing the triangle and the solution using the identity. And you see it's fantastic in either way. Okay, entonces it's only given. Entonces, what do you need? You need everything. You need the rest of the trigonometry. Sine, tangent, sine is given. No, sine is given. Sine is 1/3. I need cosine. I need tangent. And the corresponding reciprocal, no? Cosecant, secant, and cotangent. Okay? Entonces we're doing the triangle, no? 90 degree theta. I suppose the hypotenuse 3 and the opposite is 1. Okay? Because according to the definition, opposite hypotenuse. Okay, and the rest is square root 3 squared minus 1 squared. And 9 minus 1 is 8. Radical 8 is 2 radical 2. Okay. Okay, entonces this side is 2 radical 2. Cosine is 2 radical 2 over 3. Adjacent over hypotenuse. Super. I like that. Tangent is 1, que is the opposite, over 2 radical 2. This is the opposite, and this is the adjacent. And leave it like that, no. Rationalize, radical 2, radical 2. Then it's radical 2 over 4. Because radical 2 times radical 2 is 2, and 2 times another 2 is 4. Radical 2 over 4. The rest is easy. 3 over 1. 3 over 1 is invisible. Not necessary to write, because secant is 3. Secant is reciprocal this guy. Is 3 over 2 radical 2. Rationalize is 3 radical 2 over 4, no? Radical 2 times radical 2 is 2, times another 2 is 4. And cotangent is reciprocal of tangent is 4 over radical 2. Rationalize radical 2 is 4 radical 2 over 2. Is 2 radical 2. The conclusion. Bueno, sine is given. Cosine is 2.
Sorry, Professor. This is a 9, right? Or is a 4?
It's a what?
Oh, it's a 4. It's a 4. Sorry, Professor.
No, it's 4. It's my weird 4. 4. The cosine is 2 radical 2 over 3. The tangent is radical 2 over 4. This is 4. Do you understand where come from this 4?
Yes, Professor, because we rationalized.
Exactly. And cosecant is 3. And secant is 3 radical 2 over 4. And cotangent is where cotangent, I lost. Cotangent is 2 radical 2. Yeah, I forgot cotangent in my paper. Okay. This is one possibility. Another possibility is using identity. Okay, I want to show you. Solution 1, using triangle. Solution 2 is using identity. Entonces, I know one famous identity que say que sine square theta plus cosine square theta equal 1. Entonces, you have in your hand at the beginning is given sine. Suppose que I need to find cosine. Okay, so cosine square theta is equal 1 minus sine square theta. Entonces cosine square theta is equal 1 minus square of sine, que es 1/3, que es 1 over 9, ¿no? 1/3 square is 1 minus 1 over 9, ¿no? And you put together this common denominator is 9. Entonces 9 minus 1 is 8 over 9. Cosine square theta is 8 over 9. Now find square root both sides because I need cosine, no cosine square. And square root 8 over square root 9. Square root 8 is 2 radical 2. And square root 9 is 3. Boom, we get the same answer. Look at that. Using triangle, Pythagorean, or identity. Either way. Now, suppose tangent. Tangent, you know, is sine divided by cosine. It's another identity. Tangent identity. Sine is given, it's 1/3. And cosine is, I computed before, it's 2 radical 2 over 3. You divide two fractions. It's 1/3 times 3 over 2 radical 2. It's all because the 3 is cancelled. You cancel here or cancel here either way. It's 1 over 2 radical 2. Rationalize, radical 2, radical 2. Radical 2 over 2 times 2 is 4. Boom, same answer. Same answer. Same answer. And secant and cosine and cosecant, bueno, es de recíproca. You apply reciprocal. Okay, no problema. I understand. Suppose cosecant. Suppose cosecant first. Cosecant. Cosecant is reciprocal of sine. Okay, entonces flipe that, ¿no? Flipe. What is the sine? Es 1/3. Es 3. Entonces, si sine is 1/3, cosecant is 3 over 1. And 3 over 1, you know, when the denominator is 1, it's invisible. 1. Es 3. And secant es reciprocal. Secant es reciprocal of cosine. Cosine is this guy. Entonces 3 over 2 radical 2. Rationalize, radical 2, radical 2. Es 3 radical 2 divided by 4. Let me check it. Yes, it's correct. Look at it. And cotangent is reciprocal of tangent. 1 over tangent. Or cosine divided by sine. Let's do it in that way, using this identity, not this identity. No reciprocal, sino cotangent identity. Entonces, cotangent is 2 radical 2 over 3. It's a cosine, look at that here. And sine is 1/3. You cancel out this and this. It stays 2 radical 2. Wow, amazing. This is exactly the same distance. So I ask you again, what way you prefer, identity or triangle?
Identity.
Nuela say identity. Your name is Nuela, no?
It is, Professor.
Yeah, I remember you now. Okay, guys. Okay, let me explain a new thing. Let me explain a new thing to go directly to the most important part of today. Okay, I can erase. Okay. You see that the name is similar. Suppose sine. Okay. Let me draw a triangle. Right triangle as always. 90 degree here. Okay. This angle I want to call A, and this vertex is capital. This is the typical notation. The vertex is capital letter and the angle is little or Greek, theta, beta. This is B, vertex. And this is the angle B. And this is C. And this is the angle C, que by the way C es 90 degrees. Ok, entonces, what's the idea? La idea es de complementary, o sea, what is complementary, what is the supplementary in geometry? Angle A plus angle B is equal to 90 degrees. They are complementary. Because you know that the sum of the inner, so A plus B plus C is equal to 180 degrees. Okay, the sum of the three inner angle inside is 180 degrees. But si you assume que this right angle, 90 degrees is obvious, 90 degrees in C, A and B are 90 degrees. And this idea is called complementary. Two angles are complementary when the sum is 90 degrees. Example of the complementary, 30 degrees plus 60 degrees. They are complementary. 50 degrees, 40 degrees. 45 degrees, 45 degrees. They are complementary. And supplementary, no. Supplementary is when the sum is equal to 180, but I don't want to touch this. Supplementary 180. Complementary is the most important now, is when the sum of the angle is 90 degrees. So when the angles are complementary, something amazing happens. Look, we have cofunction. 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 And what means cofunction? Do you know sine and cosine? Look like the same name, no? But you see cosine, sine, cosine. It's because cosine is the cofunction of sine. What means to be cofunction? Cofunction means that the sine of B is equal to cosine of A. Because A and B are, well, let me use in no capital. Sine of B and sine of A. Si you assume que the angles are complementary, the cofunction, o sea, in other words, sine 30 degrees is equal cosine 60 degrees. Because 30 and 60 are complementary angles, and the function is equal to cofunction. Co. And similar situation happen tangent, cotangent. Tangent, for example, tangent 30 degrees is equal to cotangent 60 degrees. Because 30 and 60 are complementary angles and matching according to the cofunction. So the family of the cofunction is sine matching with the cosine. The cofunction. Tangent matching with the cotangent. And secant matching with the cosecant. Likewise, o sea, for example, secant 50 degrees is equal to cosecant 40 degrees. Because 50 and 40 are complementary angles and matching with the cosecant. Do you understand very well the cofunctions? Okay, let me write here quickly. Sine B is equal to cosine A. Cosine B is equal to sine A. Tangent B is equal to cotangent A. Cosecant B is equal to secant A. Secant B is equal to cosecant A. And cotangent B is equal to tangent A. And remember, this idea is clear when they are complementary. Si no complementary, no. It's clear the idea? Let's practice. Using the complementary angle theorem. Suppose compute secant 28 degrees.
Professor, so complementary angles are cofunctions?
It's the same.
Okay, thank you.
Suppose compute that. Compute example A and example B. Sine 28 degrees minus cosecant 62 degrees. Wow, I have no idea. But I discovered, wow, look at that. 28 and 62 together is 90, no? It's 10 carry the 1, 90 degrees. So we discovered that 28 and 62, they are complementary. Therefore, si you copy that, secant 28 minus, entonces, what is the conjunction de cosecant? Es secant, pero secant de complementary angle, que es 28. Wow, it's the same, right? It's 0, the answer. Make sense? Make sense or no?
Yes, it does.
Why is it secant 28 degrees again?
See, why is secant 28? Because I take advantage of the property for the cofunction, no? I know that the cofunction of the cosecant is secant. The cofunction of the cosecant is secant. Look at that here. But the only thing we need to state the relationship between A and B. See, A and B are complementary. I prove here that 62 and 28, they are complementary angle. Therefore, the cosecant 62 is equal to secant 28. And secant 28 cancel out, 0. Is the answer. Make sense? It's confusing or no?
Professor, I have a question.
Go ahead.
If we cosine of 62, we could change that too. Because we changed for secant, but we can change for the other function too with the, the 62.
What? No.
No, Professor?
No. You are in big trouble. We take advantage the relationship exists of the cofunction. You discover complementary. When you see this angle 28 and 62, they are complementary. This is smell. Cofunction. And what is the cofunction? Cosecant. Secant. Secant of the complementary angle. What is the complementary 62? 28. Right? No sine. No. What is the cofunction cosecant? Secant. You can do it in this way. You can do it another way. Look. Suppose that you prefer doing that way. Look. I transformed this secant and cosecant. Pero cosecant of the complementary, que es 62. Minus, and it stays the same. And the answer is obvious, que 0 again. Right?
Right, Professor. That was my question, actually. I thought, like, if we can change for the other function, that it was cosecant.
Entonces you are in big trouble. This is more complicated. I promise, guys, we are doing kindergarten part of the trigonometry now, okay? I promise that you see a horrible thing with me, okay? So little by little, I try to train to you, okay? There are several possibilities, several. I promise, this is very complicated subject because you need to memorize all of information. That is the reason I sent to the first day the cheat sheet. This cheat sheet is your friend. Well, I am your friend, no? I am your friend, but this cheat sheet is another friend that you have. Okay? Suppose example B now. It is sine 35 degree divided by cosine 55 degree. Compute that, please. Entonces immediately you say, wow, 35 and 55 is 90 degrees, yes or no? They are complementary. Okay, yeah, I know very well that the cofunction of the sine, for example, a sine, I copy exactly the same. Si you transform a cosine like a cofunction que es sine, you copy here the complementary angle que es 35. And sine 35 divided by itself is 1. Good? Good or not good?
Good, Professor, good.
One more. Tangent 35. Multiplication. Secant 35. 55, sorry. Tan cosine 35. Compute that. Boom. I have no idea. Okay, there are many ways to do this. Many. No infinity, but a lot of way to do. For example, I make a decision, apply the tangent identity. The tangent identity is sine over cosine. Sine 35 degree divided by cosine. 35 degree. Time. Secant. I don't like secant. And this is different angle, 55. But I know that 55 and 35 together is complementary. So immediately I replace by the cofunction, que es cosecant 35. Make sense or no? Multiplication by cosine 35. Wow, nice. I like that. Because everything using the same 35, 35, 35, 35. This and this cancel out. And well, I have no idea. Sine divided by cosecant. I know que cosecant es recíproca, ¿no? Entonces sine 35 degree. Multiplication by reciprocal is sine 35 degree. Okay, it's sine divided by sine, no? Divided by itself. The answer is obvious que 1. Okay, the thing I did in this example was a combination. Cofunctions and different identity. The first identity I using was the tangent identity. Tangent is sine over cosine. The other thing I using was cofunction. Cofunction secant is cosecant. The complementary get 35. Well, in the last step, I using the reciprocal. I know que cosecant is reciprocal sign. You know, red, blue, and green tools.
Professor, can I take a picture?
Take a picture. It's yours.
Okay, I already took it. Thank you.
Okay, one more example. I can erase? Erase or no?
Yes, Professor, you can, yes.
Okay. One more example. Suppose 1 minus cosine square 20 degree minus cosine square 70 degree. Compute that. Boom. Wow, I'm in big trouble. No, because I discovered that 70 and 20 are complementary. Yes or no? Entonces you replace maybe, I don't know. In this case, this is no cosine, it's sine. Sine square 70 degree, no? Okay, remember I change cosine to sine because they are cofunction, no? And using, of course, inside the argument, the complementary angle. And this leave it like that. So it's much better for me understand when you have the same angle. So I change 20 to 70 or 70 to 20, it doesn't matter, the order is not important. And now you factorization here, the minus outside, sine square 70 degree plus cosine square 70 degree equals something. And I know the Pythagorean identity is saying sine square plus cosine square is equal to 1. 1 minus 1 is 0. Okay, entonces in this example, I'm using cofunction here. In this step. And in this step, I'm using the Pythagorean identity que say que sine is equal to any angle plus cosine is equal to any angle is equal to 1. Super good?
Yes, this one was easy, Professor.
Yeah, this is no big deal. So far, no big deal. Okay, guys, so now we spend the rest of the time. 15 minutes. I finish in 30, no? 30, yeah.
Yes, Professor.
We finish, okay. We study the important, the common angle. What is the most common angle that we studied last time? Last time we studied 0 degree, 30 degree. Okay, so basically we have two super famous triangle. The first triangle is, look, that triangle. que es 45, 90 degree. So 45, 90 degree. This is famous. Y I assume normalization que this length is 1 and this length is also 1 because makes sense as isosceles triangle because the opposite angle is the same. And my sketch is not clear, but is correct. It's a 1, it's a 1, and it's a radical 2. Well, it's 1 square plus 1 square. And 1 square is 1, and 1 plus 1 is 2, a radical 2. So we compute the 6 trigonometric function for this triangle. Sine 45 degree, cosine 45 degree, tangent 45 degree. And the rest is the reciprocal. Cosecant 45 degree, secant 45 degree, and cotangent 45 degree. Well, definition, remember definition, opposite over adjacent, opposite over adjacent, 1 over radical 2, no? Rationalize radical 2 over 2. Guys, and you need to memorize this. Okay, oh no, let's see, I want to explain in the next class a shortcut to memorize this. And cosine 45 degree is the same. It's the same as radical 2 over 2. Because in this case, a coincident que the adjacent is 1. And tangent 45 degree is opposite divided by adjacent, que 1 divided by 1 is just 1. Wow, it's easy. Radical 2 over 2, radical 2 over 2, and 1. And the triangle 45, 90 degree, que is important. Now, cosecant 45, secant and cotangent. Cosecant 45 is reciprocal this guy. It's 2 over radical 2. Rationalize. It's 2 radical 2 over 2. It's just radical 2. Secant is the same. Radical 2. And cotangent is 1. Wow. It's the set of the 6 trigonometric function and the famous 45, 90 triangle. Okay, let's see another famous. Another famous is this triangle. Look, this is a little bit small. No good. It's right. It's 30, 60, and 90 degree. And you know 30 and 60 are complementary. This is the famous triangle 30 degree, 60 degree, 90 degree. And to normalize, I assume that this is 1. This is 2, and it's a radical 3. Okay. Okay, suppose que I don't know exactly, no? Bueno, I know that 1 and 2 is the hypotenuse. Okay, entonces radical 3, I have no idea. The radical 2 square minus 1 square. This is 4 minus 1, que es radical 3. So we are ready to find the trigonometric function. Sine 60 degree. 60 no. 30 degree. Cosine 60 degree. 60 degree no, 30 degree. Let's do everything for 30 degree because I know que 60 degree is the complementary, es entonces cofunction. And tangent 30 degree. Entonces sine 30 degree is opposite over hypotenuse, 1/2. Everyone in the world knows that sine 30 degrees is 1/2. Cosine is radical 3 over 2. And tangent is 1 over radical 3. And when you rationalize, it's radical 3 over 3. Okay, now cosecant 30 degree is 2 over 1. Secant 30 degree is reciprocal this, 2 over radical 3. Rationalize. is 2 radical 3 over 3. And tangent 60 degree. Why 60? 30 degree. 60 after. Is reciprocal of this guy. Que by the way is radical 3, no? Because you take this and flip it, it's radical 3 over 1, que es radical 3. And let's do it by 60 degree now. Okay, 60 degree is the complementary angle 30 degree. Therefore, the sine 60 is equal to the cosine 30 degree. It's radical 3 over 2. You only copy this guy and paste here because they are complementary. Make sense? Likewise, cosine 60 degree is 1/2. You copy this guy and paste here. And tangent 60 degree is tangent 30 degree, pero es tangent 60 degree is radical 3. Is equal the tangent. Oh, this is cotangent. Sorry. This is cotangent. It's obvious, right? Cotangent. The cofunction of the 30 degree. Now, reciprocal. Let me see reciprocal this. This is 2 over radical 3. Radical 3, radical 3 is 2 radical 3 over 3. It's exactly the same. Cosecant 60 degree is exactly the same secant 30 degree. Cofunction. Secant 60 degree, I suppose que es 2. Que es exactly the same the cofunction of 30 degree because it's complementary angle. And cotangent 60 degree is the tangent, this guy. Look. Using the cofunction idea. However, see, I don't remember, no problem. You flip it up, 1 over radical 3, rationalize, radical 3 over 3. Okay, so now I want to summarize everything in one famous table. Look at that. This table contains 1, 2, 3, 4, 5, 6, 7, 8 columns. Okay, theta in radian. Theta in degree. Don't worry, if we don't finish this table, we continue next time. Sine, cosine, tangent, cosecant, secant, and cotangent. Okay, and we start for the first. Suppose 30 degree is the first guy. The row is. You change to radian is pi over 6. Let me repeat the formula. Formula is easy. You divide 30, divided by 180, and multiply by pi. Cancel out this. 3 divided by 18 is 6, pi over 6. Sine is 1/2. Cosine is radical 3 over 2. And tangent is radical 3 over 3. And secant is 2. And secant is 2 radical 3 over 3. And cotangent is radical 3. Okay, you copy this table. You can use it anytime. After I want to explain in the unit circle, the mnemonic device to remember this. Relatively easy. Relatively easy. No easy, relatively easy. 45 degree. 45 degree. 45 degrees expressed in radian is pi over 4. And sine 45 degrees is radical 2 over 2. Cosine is exactly the same because I isosceles triangle. Tangent is 1. Cosecant is radical 2. This is radical 2 also, and this is 1. Easy, easy, easy. And now pi over 6. Pi over 3, sorry, que es 60 degrees. 60 degrees is pi over 3 in radian. Cosine is radical 3 over 2. 1/2 radical 3, 2 radical 3 over 3, 2, and radical 3 over 3. And then entonces what is the, I need to memorize this. Well, yes, but a little bit. You try to find a more device. Look, it's easy, it's easy. Focus it in that part. Focus it in that part. Suppose I put it intentionally to memorize one radical, 1 square root 1, 1 radical, and radical 1 is 1. So you know this radical is actually invisible, no? Entonces 1, 2, 3, and divided by 2 always. And the order is 30, 45, and 60. So you memorize this column super easy. Yes or no? 1, 2, 3 divided by 2. And this is exactly the same in opposite direction. 1, 2, 3. It's the only thing you need to know. Because tangent, you compute by division. You compute sine divided by cosine is tangent. Cosecant is reciprocal of this. Secant is reciprocal of cosine. And cotangent is reciprocal of tangent. Wow. So the only information that I need to remember is the column of the sine. I copy 1, 2, 3, 1, 2, 3. Of course, this is 30 degrees, 45 degrees, and 60 degrees. Divided by 2, divided by 2, divided by 2. Square root, square root, square root. And this is square root also. Or not necessarily square root here because it's 1. That's it, right? This is the column of the sine. I got it. The column of the cosine you can put in opposite direction because it's the complementary. So this is radical 3 over 2, radical 2 over 2, and 1/2. And this, no. This is division, this divided by this. Sine divided by cosine. 1/2 divided by radical 3 over 2, and so on. Do you understand it's no big deal? We practice more. We practice more.
Professor,
You need to... Say again?
Can I ask you a question?
Go ahead.
Yes, Professor, with those angles, we can find the other ones, right?
Yes, yes, yes. I assume, in the supposition, I assume the two famous Nuela triangle, 45, 45, 90, and 30, 60, 90, right? This and this, the famous triangle. I assume que es 90 degrees the third angle, yes. Okay, guys, so now we finish. You have to continue. Okay, I forgot to say something important. My schedule, like a totally changed. Now it's not Friday, it's Wednesday. I am in the lab online Wednesday from 11 a.m. to 5 p.m. Okay, you get in. As for me, I put in my private room. I explain everything you need. So I suppose that you are doing the homework. I suppose that you doing signing. You are doing signing and Alex, and you start doing the homework. Remember, the test and the homework is very, very similar. And those are super smart. Do the homework first, no? And you get extra point, 10 extra points for the homework. Good or not good?
So, Professor, another question. Do we have a practice exam on Alex?
Yeah. Do you see in the syllabus? Okay, before the test, I dedicate 2 days doing the review.
Yes, I saw it. Okay.
So no problem. You have no excuse to understand. Everything is clear. Everything is